Oh, there we go.
Hey, everybody. We're live here. Oh, we've got some echo going on in our... thanks for joining us, everyone. We'll get started in just a few minutes. If you can hear us out there in the internet world, could you type something into the chat? Hey, Rich.
Hey, Rich. How are you?
Thanks for joining us. Hey, Bob. Greetings from California.
All right.
All right, great. Well, thank you, everybody, for logging in and hanging out with us. I'll try to get Robbie's face out of the chat window. Welcome to PocketLab World Headquarters, located in sunny San Jose, California. We are going to go over a few questions and answers that we've been getting. And if you have other questions, just type it into the chat window, and we're happy to take any questions that you have. And we'll just make this brief, and if there's more interest, we'll do another live event in a couple weeks, just before the campaign closes. And hopefully we'll have more questions and more Kickstarter friends by then, and a new audience to talk with, or you guys can come and hang out with us again. So I guess just to start off, my name is Clifton Rusboom, and I'm the founder of PocketLab. Started working on PocketLab in October of 2013 as I was finishing up my PhD. And the mission for PocketLab was to make hands-on science learning fun and engaging and accessible for students and citizen scientists and teachers around the world. And from that mission, we've launched 3 products. And now PocketLab Air will be our 4th product, and back on Kickstarter to do it again. So thank you guys on Kickstarter and all of our customers and users out there for being with us since the beginning. And so here's Robbie. He's in charge of curriculum and education here at PocketLab.
Yeah, I'm Robbie. I was a former teacher, taught in the classroom for 6 years, and joined PocketLab a couple years ago, and have been working with Cliff and Dave on the education side, working on curriculum, working with the community of users, great users like Rich, who's on here now, who's published a ton of lessons for PocketLab 1 and Voyager and Weather. So been a lot of fun helping to bring more hands-on science learning into more classrooms. So really excited about that.
And Dave is in the background working away. He's in charge of all of our operations and marketing, and our co-founder. So some background on PocketLab Air. The story behind PocketLab Air is we've been thinking about this product for a long time. We've always thought about what kinds of science experiments would be really interesting when you network users together. So if you have a community of people focused on a particular topic, or if they have new capabilities that they can go out in the world and explore with, what's possible. And so the idea for PocketLab Air has always been in the back of our minds with, if you have 10,000 users spread out over the country contributing data, what would be really interesting to put onto a map and to examine together as a community. And we think that going out and measuring emissions and pollution so that you can study climate change and air quality really fits that bill. So it's something that we can work on together, and the data becomes much richer and more interesting as we work on the science together. And then it's a really big topic, and it's something that not everybody understands. It's very complex. Climate and weather science, it's a system that's very complex. And so we started thinking about an air sensor for science applications a long time ago, and we spent the last year starting to develop the prototype and think about what are the capabilities to put into a PocketLab Air sensor. And so that's what we arrived at with our campaign. The device you see there, we wanted to be able to measure carbon dioxide because that's something that everybody understands and is really relevant to climate change and global warming. So that was a priority. Particulate matter is really important for air quality, and it's got a lot of very localized changes. So particulate matter will change if you go from a highway and just move a few hundred feet away from the road. So it has a lot of geographic changes, and that you can't see and measure with existing equipment. And then ozone is really important because ozone. What's the saying, Rami?
Good up high, bad nearby.
So
ozone.
So yeah, good up high, like the ozone layer is what protects us from radiation from outer space. The surface level ozone contributes to smog and other pollution. So ozone is another thing that we hear about in the news related to smog, but not everybody understands. But it is something that we'd love to go out and measure and explore. So combining those three things, carbon dioxide measurements, particulate matter, and ozone into a device, and then making that easy to go out and take measurements was our goal. And then you need to be able to measure weather conditions as you're going out and doing measuring these air, chemical gas concentration. So with PocketLab Air, you can also measure air temperature, barometric pressure, humidity, and then there'll be light intensity. And then, so those are the measurement capabilities. And our goal with this device is for you to be able to go out in the world and take air measurements on a lot of different activities. So on your commute, on a hike, in a school, exploring the air in the school, in the school garden, out by the pickup and drop-off zone, for you to be able to take this portable measurement device and move it around with you. So that's been the goal. And we are really excited to bring it to you and excited about the response so far, about everybody that's pledged to the campaign already and is getting ready for this device. So we are working hard on it. And so I'll show you, I guess I'll show you the types, and then I'll run down some questions that we've gotten from our user community so far. So I think, like,
there we go. I was gonna say, I'll after Cliff shows the prototypes, I'll kind of read out the questions so Cliff can answer them. So Anthony, we'll get to your question in a second here.
Yeah. So here's a little prototype history. I think, like probably any good hardware product these days, it started off with an Arduino and a breadboard and our sensor components. So this little device is our CO2 sensor. That's what it looks like. This metallic box is our particulate matter sensor. It's got a fan over here to draw in air, and fortunately I don't have the ozone sensor handy. But this is, I think, how most hardware prototypes start out these days. You get an Arduino board, and then a bunch of wires, and then our components. So there is the basic. And then after some testing, we put it into a project box and close it up. And so we could go out in the world and make measurements and do some preliminary testing. So this was our second level prototype. Looks kind of like a bomb, but it's just an air sensor. And then we moved on to some nicer looking 3D printed cases where we could stuff the electronics in here. And then finally arrived at the case and the design that you see in the Kickstarter campaign. So it's been evolving quickly over the last couple months, looking more and more like a product. And at the heart of the sensor is this board that we have built off of from our PocketLab Voyager and PocketLab Weather devices. So we're able to reuse the microcontroller and the Bluetooth hardware that we built for PocketLab Voyager and PocketLab Weather, so that we can speed up the design process and get this to you as quickly as possible. So this is the heart of the system that controls all those sensors that you see. So it's got a microcontroller, the power regulation, and the Bluetooth communication, and then onboard memory on this board. And then it's connected through connectors to the other sensors, to the particulate matter, ozone, and CO2 sensor. So that is the basics for the hardware. And then for the app, if you are familiar with PocketLab, we're going to be integrating with our base PocketLab app, but adding some new data visualizations and ways for you to see that air sensor data. And a lot of that is ongoing. You can see the prototype on our campaign page, where you have those dials that are overlaid on top of the video and images that you can collect with your smartphone. And we're going to be doing more of that. And we're really thinking about data visualization, so you can better understand what's the meaning of the sensor data and put that into context. Because if you show a CO2 reading that says 432 ppm, is that good? Is that bad? Is that what should it be? Like, what is the context for that? That's really important to the learning, and that is something that we will be working really hard on. And we had a call on Monday with the EPA to discuss ways to visualize data and represent it in a scientifically accurate way. So we are drawing on experts to be able to do that. So that's the background.
Yeah, we can answer a couple questions that we have so far.
Yeah, let's take the user questions.
So one's from Anthony. He says, he has two questions. Will the product detect nanoparticles such as heavy metals? And then the other question, Anthony, we'd love to be on your TV show. So go ahead and email me at robbie@thepocketlab.com, and we can talk about that. And so if there are other questions too later that you have, you can also email me directly at robbie@thepocketlab.com for anybody, or contact@thepocketlab.com. Both those emails go to me. So I answer all those. So I'll let Cliff answer Anthony's first question.
Okay, so can it detect nanoparticles? And the short answer is no. We do detect particles. So our particulate matter sensor can detect particles that are roughly 0.3 microns to 1 micron. So that's called PM1. 1 micron to 2.5 microns, PM2.5, and then the bin 2.5 to 10 microns, PM10. And so we can get individual readings for each of those size categories. But our sensor, the limit for any particle that it's designed to detect is 0.3 microns, so 300 nanometers in diameter. So we can detect hundreds of nanoparticles if they happen to be conglomerated together, but not individual nanoparticles. And we would love to know sort of the application for that, and it's something for us to consider in future products.
Great. And then, do you open source your designs, and how do you deal with calibration?
So our hardware and our app are not open source, but we will provide a method for you to get that data. And our intention with PocketLab Air is to build an API in a web layer, so that if you have a website or anything else that you want to interface with the data, you would do this through web methods. There's our office manager,
hi,
Renata.
Hi.
And so we are going to develop an API that is going to live sort of in a web layer. The sort of design schematics and the firmware and that stuff is not open source, mostly because we're a small team and we don't have the resources right now to sort of support open source hardware and some of these like more maker ways to interact with our product. But it's something to consider in the future. But so there will be a way for you to get PocketLab Air data and integrate it with other projects that you have, which I think is what we get a lot of requests for.
And then about calibration.
Okay, yeah, calibration's a great question, and we will factory calibrate it. We're working very closely with our sensor manufacturers to have calibrated measurements that we get from the supplier, so that we can hit our accuracy and specs and requirements. We are devising ways to continue to calibrate that in the field, and I think there are a lot of approaches, and we're trying to figure out the best ways. For example, using a nearby like EPA monitoring station, you could go travel there, and using our GPS data, we could know that PocketLab Air and the EPA station are in close proximity, and we could do some sort of automated calibration to this research grade kind of equipment. That would be one method. There are also ways that you could expose PocketLab Air to a known concentration of CO2 or other gases to do a calibration. There are methods that we're exploring. We don't exactly know what our approach will be, but it will come calibrated when you receive it, and it's something that we'll learn more about as we get further in our production process.
Great. And then what type of CO2 and ozone sensors are you using? That's from Jessica.
So our CO2 sensor is it's an optical sensor. So there's a emitter and a collector and an optical pathway, and so it emits at the wavelength that CO2 absorbs. And so this is an accurate, low-cost way to do CO2 sensing. So it's an optical measurement. For the ozone sensor, we're using an electrochemical sensor that's that is from a company called Spec Sensors, and we're working with them. They're near us in the San Francisco Bay Area, and so that's an electrochemical transducer. And then the particulate matter sensor is also optical. There's a fan that pulls in air, and then there's an optical detector that is counting particles as it moves through the sensor.
Yeah, and so as a follow-up, maybe some questions about the accuracy of the sensors.
Yeah, it's a good question. We have the specific, we've got the specs on our campaign page, and but but to try to put that into context, so the particulate matter sensor that we're using was that component has been used in other products that have been evaluated by the EPA and other air quality regulators, and it was the best performing sort of low cost device. And so we're talking low cost being hundreds of dollars, not thousands of dollars. So the component was the best performing low cost device. So that's what we selected. And if you want specific numbers, they're in the campaign page.
Yeah, about 3/4 of the way down, you'll see a spec sheet.
Similarly, the CO2 sensor that we're using for low cost devices, this is less than 100, or the components are less than $100, not thousands of dollars, is the highest accuracy device on the market. It's from a company in Scotland called Gas Sensing Solutions. And then for ozone, the part we're using is one of the few small scale ozone sensors. So this is a new area of research and development, and we think that's also been tested by the Air Quality Management District, the South Coast Air Quality Management District, and it performed well, and it's one of the few options that you have for measuring ozone, and so it's the best thing on the market that we could find. So yeah, I don't remember all the numbers off the top of my head. They're on the campaign page, but to put the specs in context, they're the best low cost sensors that we could find on the market. And by low cost, when you're talking about air sensors, means that they go into devices that cost hundreds of dollars, not thousands of dollars. Air sensors can get very expensive. So we did a lot of homework to find the best performing low cost devices.
And then Rich has a question about the light sensor to read at least 100,000 lux.
Yeah, so Rich is a user of PocketLab Voyager and PocketLab Weather, and we, on that sensor in Voyager, we can't go up to really bright light levels that like indirect sunlight. So we'll be using a different light sensor for PocketLab Air so that you can measure the light if there's full sun, which can be 100,000, 120,000 lux in direct sunlight. So yes, Rich, we'll select a different component so that you can have a full scale measurement while you're outdoors. Would you provide calibration, degradation, characterization for the sensors you select? Yes, it is something that we have to work with our manufacturers to get, and we will hold our component manufacturers to their quality requirements. It is something that we're working on, and we know that's important. So yes, but it's in process.
So yeah, Bob wants, he doesn't want to drop PocketLab Air from an aircraft, but what kind of treatment will the device take?
So drop protection, we haven't tested that yet. We have too few prototypes to sacrifice to dropping them. I can tell you with PocketLab Voyager, our physics device, you could drop that onto a steel plate 20 times and it wouldn't break. But that is a small device. So by comparison, here's how big PocketLab Air is, and so there's a lot more mass here. So I don't think this would survive being dropped onto a steel plate 20 times. But Voyager is meant to be put on rockets. You're not going to launch this on an Estes rocket. We are designing PocketLab to stand up to abuse by a middle school student that doesn't treat the device like a precious instrument. We haven't done drop testing yet. There are movable parts in PocketLab Air. There's a fan that's inside the particulate sensor to draw in air. So if you have movable parts, that means it's not as drop proof as something like PocketLab Voyager, where it's just circuit components. There's nothing mechanically moving. So I don't have a great answer for you yet, but we will make it as durable as we can.
Yeah, and Jessica's asking about the price. It's listed on Kickstarter. It's $248. We did open up some another round of early bird pricing, just to let everybody know for the for Cyber Week, for all the sales going on. So right now you can get the early bird for $198, but she's asking about what will the list price end up being, and how are we going to try and keep prices low for consumers?
Good question. We think the list price is going to be $298 once we get into production. So for pre-sale right now, it's $198 if you grab some of the remaining early bird, and then $248 during the duration of our Kickstarter. We will provide educator discounts for people that want to purchase for their classroom. Everything, we sell the hardware, everything else is free. So the app is free, all the lessons and curriculum, that's all free. We are a small company, and we're trying to keep costs down. As you can see, you're in PocketLab global headquarters. So we try to keep the cost down. And if you compare the functionality of PocketLab to other devices, you could expect to pay $300, $400 for just a particulate sensor, $400 just for an ozone sensor. So what we're trying to do is give you everything you could need for less than you'd pay for one traditional piece of low-cost equipment. So we're doing what we can. We're a small company, and if you can help us reach more people, we can scale our manufacturing, and we can bring that cost down more. So, so that's what we know for now.
And then Rich is asking about a protective rubber type cover, or would that be impossible with the type of sensors like we have for PocketLab?
Yeah. So at the very least, we will have a zippered case like we do for PocketLab Voyager, so that if you put it in your bag and you're traveling around, you can fit PocketLab into something like this, and there'll be a custom slot to hold it firmly in there. I don't know, we'll look into having like a rubber protective case. One thing we need to make sure is that we have really good airflow through the device. So the accuracy of our measurements depend on how well we can get air to circulate through there. So anything we design can obstruct airflow. And then we need to pick materials that couldn't possibly affect our measurements. So if there are rubbers or plastics that could outgas chemical gases that would affect our ozone sensor, for example, we need to make sure that that doesn't happen for measurement accuracy. So we haven't designed a rubber sort of protective case. We know we will provide these zippered cases with it. Something to be determined.
And then would you hope that the EPA would endorse this product? Maybe even find its readings useful in court?
So the EPA evaluates what they call low-cost sensors. They consider anything less than $1,000 to be low cost, because an EPA piece of equipment to, let's say, measure particulate matter costs $50,000. So we will be working with them to evaluate PocketLab Air and test it against their reference material. What the requirements for a regulatory piece of equipment are really high, and that's why they cost tens of thousands of dollars. And PocketLab Air will never be used for anything regulatory. It will be great for you to go out and get measurements that agree very well with high-grade, high-cost instrumentation, but we will never have sort of the resources or the types of sensors that cost hundreds of dollars, do not pass the EPA sort of benchmark to be used for regulation. Those are tens of thousands of dollars. So, but we're trying to work with the EPA as much as we can.
And are you? Oh, and then Bob is asking about Purple Air and whether we're aware of them and if we could partner with them.
Yeah, we're aware of them. They make a really great particulate matter sensor, and then it also functions for, I think, weather measurements, temperature, humidity, barometric pressure. It's designed to be a station, so you put it on the side of your house. Yeah, we love what they're doing, and we'd like to explore ways to work together. PocketLab Air, as you guys have seen, the design is different. It's not meant to be a station that you leave on the side of your house. It's meant to be taken out so that you can move around and collect data in active experiments. So yeah, they're a little bit different, and maybe there's ways we could work together. So I have a few questions from Kickstarter that we've been emailed over the last couple weeks, and I wanted to share those with you guys because they might be questions you also have. A lot of questions about the particulate matter sensor, which we already covered, but we will give 3 readings from the particulate sensor for the different size particles. So PM1, PM2.5, and PM10. And that's not shown on the video because it's a prototype app that we were showing, but in production, the particulate matter sensor will have 3 data points. We talked a lot about factory calibration and accuracy, and we're working on that. It will come calibrated, and we are developing ways for you to do calibration in the field. So our PocketLab will be able to operate both wirelessly, so it'll send data via Bluetooth to a connected device, and it can record data on board to memory. And we are designing it so that you can continuously operate PocketLab Air in data logging mode for 24 hours or more, depending on which sensors you have active. But if you turn on all the sensors and collect data, we want it to last for 24 hours, and then for you to go up, retrieve it, and download that data. We are looking at ways that you can duty cycle PocketLab Air. So there'd be a continuous measurement in offline mode and a way to turn off and turn back on and turn off and turn on so that you could have longer term experiments. It's something that we're working on, and we'll have to figure out the design and how that gets implemented. But we've had a few questions about that, and it's something we are aware of and we're working on. Had a few questions about mapping, and what you'll be able to do is collect the data from PocketLab Air and then sync that with your GPS location on your phone or tablet. So we will get GPS data from whatever device you're connected to. And that's important for a couple reasons, because one, GPS takes a lot of power, and if it's coming from your phone, that means we don't have to drain the battery of PocketLab Air. And then it will keeps the price lower, because we can use some of that technology in the device that you already have on you, and you don't have to pay for that to be inside PocketLab Air. So mapping will come from PocketLab Air data connected with the GPS location from your phone.
And then, and just to kind of continue with that, we have we're working on this. Cliff talked about earlier, this PocketLab mission mode, and the idea behind that would be that users, PocketLab users, or us from the PocketLab team, or researchers that maybe we're working with or that are interested in collecting data from PocketLab Air users, we could create PocketLab missions, which would be experiments that users, experiments, investigations, projects, whatever, that that PocketLab users could participate in. So those missions would be sent out, and then they would have protocols for how to collect the data, which sensors to use, what kind of the objective of the mission is, and then users could collect that data and upload it to the mission. It would go onto a map, and then that way we can have PocketLab Air users collaborating on sort of these global citizen science type projects where users are sharing data with each other and kind of collaboratively working on experiments, and maybe that you could do some really interesting, cool new investigations that you wouldn't be able to do just on your own, but you need other users out there using the same sensor and the same sort of protocols to collect that data. So that can be really powerful for citizen science. It can also be really cool and powerful for educators and students in classrooms all over the country and all over the world to help kind of inspire young people to be involved in climate science and to be involved in understanding air pollution and air quality. So that's definitely something that's a big part of what we want to do.
Okay, so some other questions about permanent installation outdoors. So can you install it outdoors permanently? Maybe. That's not the way it's designed. So it's designed to be portable and mobile. And if you are putting anything outdoors, you have to consider for PocketLab Air, we need good airflow in and out. So it can't be waterproof. It can't be sealed off. So there are ways you could install it that would give you good measurements and protect it. But if you sort of just took PocketLab and put it on top of your roof, that would not, and that's not how it's designed. So yes, there are ways that you can sort of install it and use it to collect data, I think, sort of in a more permanent position. That's not our first priority for the design. And there's considerations that you need to take about how can you expose PocketLab to changing weather and environmental conditions, but not get it wet or things like that. A question about data export. So you can collect data in the app. You can export it as a CSV file. That's very easy, and we do that with all of our devices. And then we are creating online software where you can export PocketLab data to an account that exists online, so that you can do these mission mode things. You can share data. You can visualize it on a map. You could share it publicly with other users. So you can always have the data privately and export it as a CSV file and take it into whatever you want. And there will also be ways for you to connect it with other PocketLab software that will be online. For anybody that purchased a Voyager and a Weather, on that tier, we will ship your Voyager or your Weather device as soon as the campaign ends. As soon as the credit card payment goes through, we will ship out your PocketLab Voyager or PocketLab Weather. So thank you for being interested in those devices too, and you'll get those as soon as the campaign closes, and we'll ship those out so December 21st, 22nd, after credit cards have been payments have been locked in. And then a lot of interest in water quality. People hear about air quality and they think, oh, are you guys going to work on water quality ever? And we hope to. We think that's one of the next products we want to design and explore is how can you go out and measure your local pond or stream or beach, ocean, and do similar citizen science experiments. So yes, water quality, hopefully, and maybe this time next year.
A couple quick questions from Rich. Does PocketLab Air need to be in Bluetooth range of your iPhone to coordinate it with GPS?
Yes. Well, we are going to base your correlate the GPS location from your phone to the measurements from PocketLab Air. So I would say yes, probably.
Yeah. But like if you were saying using it as some recording to memory or something as a station, if you were using it in a sense as a station for a couple hours, you set it out to record, and then you came back and uploaded the data.
Yeah, so you could. Yeah, so if you like, say you set up PocketLab to log data somewhere on a tree, and then you came back 4 hours later and you retrieved that data, you could mark that data with like the GPS location at a specific time, like when you downloaded that data, so that you could put all that onto a data point on the map. If that answers your question.
And then will it work? Roberta asked, will it work with Android?
Yes, works with Android if you have Bluetooth 4.0 capabilities, which is pretty much any Android device made since 2013. We will be able to support that. I think that is most of the questions. We have the other last one. We have gotten a lot of questions about adding on different sorts of sensors, new measurement capabilities. Like, can you measure nitrogen oxides or ammonia or methane? And we would love to hear about those use cases and better understand them. The answer is always yes, we could. The more capabilities that go into a device, the more expensive it is, and the more complex the engineering is. So right now, we're committed to the PocketLab Air design as we've put it on Kickstarter and as we've developed so far. But we are really interested to know what are the other things that you want to go out and measure, and why. What's the application? And it could be something that we work on as either a Pro version, PocketLab Air Pro, or another device. But all of that is really interesting to us. So please send us those questions or ideas or brainstorming thoughts, and we would like to know more. So that's already been about 45 minutes. So if there are any last minute questions, we'll take one or two more, but otherwise we'll say goodbye and go get lunch, and then we'll get back to work.
Yeah, real quick, Ruth asked, does the app require a login to submit data or just ownership of the device?
So the app, you don't have to log in. You can use it without creating any sort of account. If you want to access our tools or software online, you will need to create an account, which is free. But as it is, if you just want to connect your PocketLab Air to your phone and look at data, that works without an account.
Okay, and then any other questions, if you have any later on that you come up with, you can always email us at, you can always post a question on the comments section in Kickstarter on the campaign page, or you can email us at contact@thepocketlab.com. If you go to our website, that's in there. And that I answer most of those emails, or if I can't answer them, I direct them to people who know the answers. So yeah, email us if you have any other questions, or post a question. Also, shout out to Daphne, one of our interns who's now at UCLA, who's on the live stream. Thanks for joining, Daphne.
Yeah. Hey, Daphne. And I think we've got 20 days left for the campaign. So please share our campaign with your networks. Send an email to the people that could be interested in this. Your recommendation is the strongest support that we could get, and that means a lot to us. And we're very thankful for everybody that's supported our project already. And if you can help us spread the word, we really appreciate that. And we're working hard to build the best device we can and get it to you guys so we can go out and explore together. So
yeah, and I'll just Kalen, yeah, anybody that came late, this video will be on our campaign page.
Yeah.
So you can go back and watch the whole thing.
Yeah, Kickstarter automatically uploads it to our campaign page.
Yeah.
So I don't know if it goes up right away, but it will be there for review. And so yeah, check it out.
Yeah, and continue to share, like Cliff said. And the more people that support the campaign, the more people that get PocketLab Air, the bigger community we have for really cool projects like Mission Mode, and the better we will be able to get it into the hands of more teachers who can do more cool projects with their environmental science classrooms, and the more people we will reach and kind of inspire to become advocates for the environment and for working on these really big issues that we're all facing. So share with everybody.
So thank you guys so much. We'll probably be back before the campaign ends with another live event. Maybe we'll have a little party like just before the campaign closes. So hopefully see you guys again.